Hey, fantastic.
Okay.
Hello, everyone. Thanks for letting me sneak into your meetup. Were you about to say something there? Did I cut you off?
No, it's fine. You go for it.
Great. All right. Hello. This is me. I am usually on the internet talking about bikes and cider and crashing and trying to save the planet. I apologize for my not great sound quality. This photograph was the last known location of my Apple AirPods. I think I might have lost them in the Dune. It's a fun weekend. So I used to work at WeWork for a couple of years, and it was a hell of a time for APIs. I joined the company because a friend of mine said, our APIs are terrible. Can you come here and make them better? So I did. And the first day I said, where's your documentation? And they said, the what? There was no documentation for any of the APIs. There was like 50, eventually 100 APIs, and no one really remembered how any of them worked. Things were generally terrible. There's a lot of things on fire. At a large, very mature company that's been doing API-driven development for a long time, that's been, service-oriented architecture has been around for decades, gets rebranded and renamed, and the ideas are rejigged now and then, like microservices are just another kind of fresh coat of paint on top of the service-oriented architecture that was popular in the, 70s. But this sort of thing, this workflow here is generally accepted as a lot of the steps in having a bunch of APIs, right? You start off like figuring out what your strategy is, and then you design them and you mock them. You create prototypes to see if they're any good, and you test those. By that can mean kind of getting consumers to test implementation and play around, or it could be pilot projects, things like that. Then you implement, deploy, secure, manage, discover. I'm not entirely sure what discover means. I forget this article, but then you kind of continue to develop consumers who then you kind of monitor the information that's coming in, and you try and monetize those APIs over time if you can, productize them, and all of that kind of feeds back into the strategy part of like figuring out what to do next. So you have, you make some APIs, you plan them, you make sure they're good, you get feedback, you make them better, and things just evolve over time. So it's two different virtuous cycles, supposedly. A lot of the time, and specifically at WeWork, what ended up happening was when you were in a meeting trying to talk about a new API that needed to get done, before we even really kind of thought about the strategy of what we're going to try and do and how we're going to try and achieve it, people were writing code. They would just sit there, type Rails new, whatever the name was. If you were talking about making a permissions API, someone would be trying to code it in the meeting, just talking about it. So they didn't really have any strategy. There wasn't really any design. People would just write code. And then the entire life cycle just basically looked like this. It was just a whole bunch of code, and then go and consume it if you want, and then more code, and then hopefully money somehow, and then more code. And everything was pretty bad. Things were on fire. So my job was to try and make sense of this whole thing. And I figured the first step would be to try and get people to, document a bunch of their APIs and to try and figure out how to use these different description tools, and whether they should be writing annotations in their code base or using kind of the YAML or the raw format that these different things support. Should it be design first or code first? Why do people have to do so much of this by hand? Why are there no visual editors for this stuff? How and when do we create documentation and mocks? How are they involved? And how do we keep code and docs in sync? Because a lot of these things, you end up kind of writing some docs and then your code changes and your docs don't change. So that's a bit of a concern. So after years of researching and sending pull requests and experimenting and trial and error, OpenAPI has now become like the de facto standard of the industry. Pretty much everyone is using OpenAPI if they're building a HTTP API. There was Swagger is gone, doesn't really exist anymore. There's a tool suite called Swagger, but the actual specification is called OpenAPI now. And RAML and API Blueprint have kind of gone away. They're no longer being actively maintained as a thing. So I gave this whole talk, and right at the end of it, somebody said, what's OpenAPI? So just to make it super clear, OpenAPI is an API description format. Sometimes people say API specification or API definition, but we're using the term description format for creating HTTP API descriptions. You're describing your HTTP API. You can describe it. You can describe how it should be built, or you can describe how it has been built, right? And that's the code first or design first thing that we're going to get into, whether you do it first or second. A lot of people will describe their API with a description document. So there's the description format and the description document. And often it'll be called OpenAPI.yaml or JSON or something else. And if you aren't familiar with it, not going to go too hardcore into how OpenAPI works. There's a bunch of other talks. If you search Lorna Mitchell Introduction to OpenAPI, it's a great talk on YouTube. But basically, you have a bit of meta information about the API. You can put contact information in so people know who to talk to when it breaks. You can put in different servers. So in your documentation, people can choose if they want to play with production or the sandbox. You put in your paths. So here's the route, and you put in the methods and whatnot. Give them a name, which is handy for SDK generation. List any requests that might come in, a bunch of responses, different status codes, and you can use references, which is a cool way of like referencing other models and parts. It's kind of like an include in PHP, I guess. And you can kind of define them in other parts of the file to make it reusable, or you can define them in other files to kind of avoid what used to happen, which is a lot of people would create these like 5,000 or 10,000 line long YAML files and then complain they hated doing it because they didn't want to maintain a 10,000 line thing. You don't need to. People just did it that way and then complained about it. So hopefully I'll show how that can be avoided a little bit. Yeah, most of the stuff that people, the most important part here, you can describe the service layer and the data layer. The service layer is endpoints, methods, status codes, all of the bits of the interface, right? Like the I in the API, all of the headers and parameters, query parameters, all that stuff is kind of the service layer. And then the data layer, the data model, is kind of the JSON body of the payload. So the request body and the response body. And that is very similar to JSON schema. If you've used JSON schema, it's like 98% the same thing as JSON schema. There's a few subtle differences. And in OpenAPI 3.1, after 2 years of fighting and battling, I and a few other people managed to get rid of those discrepancies. So OpenAPI 3.1 legitimately is just JSON schema. But it will look very familiar if you're used to it. You can set, you can basically say, this is a JSON object, and it will have these different properties: name, email, date of birth, data types. Data types, this is very similar to Protobuf or GraphQL. You just say like, this is a string, this is an integer. But unlike those two formats, you can do a lot more than that as well. You can put in like max length, or you can put in format to say this is an email address, and you can put in example values or default values or enums and loads of other stuff. But again, not a JSON schema talk either. OpenAPI is, I'll get rid of that. OpenAPI is not just kind of a little project made by a couple of people. These are all the companies, not that use it, but that actually support the creation. They sponsor in some sort of way. They are involved with when they're participating in the creation and maintenance of this specification, including, you might notice, a.k.a., who made API Blueprint, and MuleSoft, who made RAML. So those folks have kind of stopped doing their thing. But they're still working on interesting products, but they've kind of given up on the service layer description format game. So OpenAPI is the thing. So with that solved in my little research attempt, I then had to try and figure out annotations or YAML. What are the pros and cons? If you're using Java, which I know some of you folks probably aren't, and you have real annotations, then annotations they are this first class feature of the language, and you can have syntax highlighting and checking, and you can use constants and do all this cool stuff. And you can basically sprinkle some of this API description stuff throughout your code. That of course assumes you've written the code first, or you write a bunch of empty methods and kind of just put them in there and then write the implementation later. But annotations are kind of one way of doing it. And it's okay when you have the annotation as a first class feature, but in PHP, it ends up looking a bit more like this. I know there's an RFC for annotations to come, and maybe that might change, but basically you just have this big, ugly blob of stuff And it's really hard to be sure that this actually worked, because there's a few of these different description formats, and you don't necessarily have tooling for all of your different, like maybe there's one for VS Code for this specific format, but not for a different one. And maybe you switch to the different one and it doesn't have VS Code support, it doesn't have Vim support, right? It's really hard to actually be sure what you're writing in here makes sense and isn't full of just errors or isn't inaccurate. And there's no real way to test that it actually matches against what's in the code either. So not ideal. And in JavaScript land, they just put Swagger and then dump that YAML straight in there. So also not great. The argument people use for using annotations is that because the description is close to the code, in theory, developers are more likely to keep it up to date. And that's almost like a verbatim quote from somebody who's a real ardent defender of annotations, but that's a lot of ifs and maybes and hopefullys and buts and shoulds, right? Just because, don't confuse proximity with accuracy. Just having something near it, the bigger that thing gets, the harder it is going to be for developers to even know that it's related. If they're just trying to change the bit of code, they can make a tweak and a new property can show up, a data type can change, or something can change in a different file that propagates through to affect how that endpoint works. And that annotation is not helpful at all. So in my experience, I've worked with this a bunch, and this quote is great. Code comments are just facts waiting to become lies. If you're more of a visual learner, then this might make you understand what it's like. Just because it's near it doesn't make it true. So on to code first versus design first. Again, this talk is a lot more opinionated than the last. I did a Twitter poll. 300 people responded. I basically asked how you would summarize the API development culture at your organization. Is it entirely design first, entirely code first? It was code first, but we're moving to design first, or it's some other awkward combination that isn't that kind of migration path towards design first. And awkward combination one, it's crazy. The API design community are really split on how to do this. There is no one true way, but there are a lot of people moving towards design first. I just love that awkward combination won that round. Basically, this is the workflow that a lot of people might be familiar with. This is how I used to make APIs before I learned about API Blueprint and OpenAPI. And basically, you start off planning somehow, whether you've got yourself a whiteboard or a notepad, or you're just writing notes in your computer, or you're doodling on a napkin at a bar. You basically plan what your API is going to do somehow. You share that napkin around to other people, to other developers who might then start doing the work, or your team, and you'll pick different endpoints to start working on. You write a bunch of code and you get some customer feedback. So you put it in staging or something, and ask a bunch of mobile developers, front-end developers, web app developers, whoever, to give you feedback on how that API works. And that can actually take quite a long time, because you have to write all the code, or write most of the code, and then get that customer feedback. And then you need to kind of rewrite a bunch of that code. And if you were doing TDD, then you spent all that time writing your tests first, and then you got the feedback. So you've got to change all the code, all the tests, everything else. And there's only so many chances you're going to get to go through that feedback cycle before you're at the deadline, and this needs to go into production. So what usually ends up happening is people say, screw it, this will go into V1, V2 can come later. We'll put all of these bits of feedback in, and you can fix that later, which is pretty, kind of sucks for the client, because they don't get what they want, and they get told from day one that they've got a lot of work coming up at some point in the future. So that's not great for them. But anyway, you deploy it, and you think, that was awesome. We got version 1 done on time. Well done us. We know that we're going to need some documentation at some point. We've only got 1 or 2 clients, and they're deployed, and that's fine. So we don't need the documentation right now. But then you've been busy kind of fixing production issues and performance issues and whatever else has come up. And a few months have gone by, and a new customer has appeared. Damn, you didn't get around to writing those docs. So the docs aren't ready, or they're kind of bad because you rushed them together. and the developers have forgotten how the API works because it was a month or two ago, or even 6, right? Like people get distracted before they write docs in my experience. So then you've got a bunch of confusing code that's kind of evolved over several months, maybe a year, and you kind of have been struggling to really keep with this specific contract, the version 1 contract. So the code's just a bit of a jumbled mess from rewrites. And so what ends up happening, especially at WeWork, they would create a brand new global version or a brand new API, mostly because they forgot how much the old one worked. I mean, sometimes they would try and look at the code and they could figure it out because they might have had serializers that would explain all the fields. But other times they'd look at the code and they wouldn't have a clue because API A talks to B and C in the background and just passes that stuff straight through. And if B or C changes, then A kind of also changes and people don't really know what the contract is. And so this is generally the crappiest of all code first workflows, right? You end up going back to the drawing board or the napkin and starting over, and it just goes on and on forever. And click raise hand if you can on Zoom if this resonates with you. There's a slight tweak which some people recommend, and that is kind of the annotations stuff mixed in with the code first workflow. So this shrinks down that whole loop quite a lot. Basically, you have the same planning process, whatever, napkin, share that around. Then you write a bunch of code. You annotate the code that you're writing so that you can immediately have documentation generated from those annotations. And then you can you can put that same API into staging or share the documentation or both. And you can get customer feedback through these kind of early prototype, beta testing, whatever period you want to call it. And then if there are problems, you still have had that very long, slow feedback loop where you've had to write a bunch of code and annotate it. It doesn't really have that much time, whatever, but you had to change all the code before you could get more feedback from the customer. So that's not super ideal, but the benefit of this workflow is that as soon as you deploy the code, you have docs already. Like you immediately have docs because all of your stuff was annotated as you went, and hopefully it's accurate, whatever, you've got docs, yay. And then when someone asks for new functionality, that's kind of okay because you can just add a new endpoint and you have the docs. And the reason I'm not a huge fan of this approach is it's kind of like, if you consider the API description to be like a blueprint for the house, right? There's a reason the format used to be called API blueprint because it's a blueprint for your API, like a schematic or whatever. And if you're going to build a new house, do you want to just randomly build it and just put it all together and hopefully things fit and hopefully it's structurally integral and hopefully it's earthquake proof? And then next time you want to get some work done on it, or you want to sell it, or you want to add an extension, do you then just kind of run around and do a sketch of that house? That doesn't really sound very professional or very useful or very accurate or very safe. And that is, to me, roughly what Code First is all about. I would rather kind of do the blueprint first, and then that blueprint can be used as documentation immediately because it's done before the house was built, and we know that things are going to work. We know that we like the look of it. You can give feedback on those blueprints and those plans before it's built. So I was trying to push design first at WeWork, and initially it was quite difficult because a lot of the tooling was a bit rough, and also it kind of I've seen a lot of other folks recommend this one variant of design first, like it's the way to do design first, but it's just one of a few different ways. Basically, you can design with OpenAPI, whether you write it by hand or whether you use a DSL or editors. We'll look at those in a sec. You design with OpenAPI, then you can share mocks and docs because you have this usable file that can be used for anything, including creating documentation or mock servers. And then you can get customer feedback. And all you've done is write a bit of YAML at this point. If anyone has any concerns, they can give you feedback. Sometimes the feedback is going to be things like, I've had to hit 25 different endpoints to get this information for this one screen. Could you maybe make some more useful entities, right? Like the data is too normalized and I'm having to go over the wire a lot. Or the other way around is this data is nowhere near normalized enough. It's just a giant, all the data's in one thing. I don't need half of this. This is just a really slow thing to fetch. So all of that sort of feedback, or can you add this property or whatever? All of this feedback can be done, and all you're doing is just tweaking a little bit of YAML. So you can both sit there together and do it in seconds instead of taking a few hours or a day to rewrite and redeploy the API. So this is a really good start to the workflow. But the problem here is that then people recommend this kind of, the design is done and you should turn it into something else now. So you take these OpenAPI files and you either generate a bunch of PHP code that you can then edit and change and tweak and do what you want with, but you can't ever kind of run that again because you'd override your code. So people recommend like generating code, and you can generate code with annotations in it. So you've kind of switched into this code first approach, or you just kind of throw the OpenAPI away and just kind of go with that code first approach. And that's not ideal, because once that's deployed and new functionality is requested, you're kind of going back to drawing ideas on a napkin. So there is another approach which solves all of that. It's the exact same first half, but instead of kind of generating code or like exporting it and importing it into some other different tool, like Postman, and using that for keeping track of everything, instead of doing any of that, you actually use the machine readable API descriptions that you've created to simplify the code that you're about to write. This can mean a bunch of things. We'll look at that. But you use OpenAPI to simplify the code with validation, stuff like that. And then you deploy that, and your docs are already available because you built them before you built the API. And then when new functionality is requested, you easily have this like up-to-date, awesome OpenAPI description that you can add a new endpoint to, or add a new property to, or kind of tweak a little bit. And people will be able to give you feedback on that, because it's back to the start of the first workflow. So at WeWork, the whole thing looked a bit like this. The development cycle would be, you write OpenAPI, you send a pull request. That will give team reviews. If the team think that the OpenAPI you just wrote is rubbish, they can say like, this is badly written OpenAPI, or they could say like the API that you're describing sucks. So the meta or the actual content can be reviewed. You can also use continuous integration to lint that OpenAPI to do the same sort of stuff that the team review is doing. The more that you can lint about the APIs being described, the more things you look out for, like don't use HTTP basic, don't use, you didn't add any pagination to this thing, we don't know what error format that is, this should be camel case or whatever. The more of those rules that you can lint, the less work the team review takes. And you can also run some contract testing, which is pretty handy. And then I built this whole complicated like API aggregator that would clone all the repos and normalize all the information and create a mock server and a spec server that would then be used to do all this. It's really complicated. And the reason I built all this myself is because the tooling that was around wasn't really very good. There was Stoplight and a.k.a. and a few of these other similar tools, but most of them would like only do half of it and would lock you into this walled garden where you couldn't really get your data out. So you could only do a few things, and you'd have to pay for all the users that you were adding, and you could only do half of it. And then you had this other, Postman or something else, some other vendor that would do the other half of the situation. And you'd have to pay for all those users as well. So you were paying loads of money to not really do what you needed. And it was complicated. So I ended up kind of doing a lot of stuff, building a lot of this myself. And unfortunately, the hardest part with this entire workflow was the write OpenAPI part sucked. The color code here is like green is good, yellow needs work, and red isn't done yet. And this was basically write OpenAPI was still write a bunch of YAML by hand, which people don't really want to do. So somebody wrote this article, and this quote I thought was pretty good. It's great for describing APIs, but it's really not a great experience for to write OpenAPI documents from scratch. If you just have an empty file and you have to start typing those keywords in there, like I forget what half those keywords are, or which order they go in. Is it content schema MIME type or content MIME type? I forget. But the same person that wrote that article, they created their own DSL because they didn't like writing the YAML by hand and came up with this. And arguably, this isn't exactly much nicer. I don't know what syntax this is, but they did this. And this just means you need your IDE might have, probably has YAML support. It might have OpenAPI support, but it doesn't have whatever this DSL support is, right? So I was trying to avoid that, and I was wondering if there's any visual editors, and there were a few, and there are a lot more now. 2 years ago when I was looking, there weren't very many, and a lot of them would kind of help you create OpenAPI descriptions. But then if you ever wanted to edit, like you'd create them, you'd export them, and then you'd have the files, and you'd have to just edit them by hand if you wanted to do anything. You couldn't like open up a project and update it through those GUIs. So most of the GUI editors were really bad. And there was Stoplight, which was, again, trapped in the walled garden. You had a desktop app that you could use, but it was just a front end for all the files that were trapped in their servers. But if you go onto this website, I maintain it, community website, and there's a bunch of GUI editors. And I actually ended up working at Stoplight because I was giving them so much feedback on how to build like a better platform and a better workflow and a better editor that we decided it would make more sense if I just worked there, because I was just giving them free consulting all the time. And we've just released a whole bunch of cool new stuff. I'm going to show you some of it. New website, new platform, new software as a service. Most of it's free, so I'm not really here to sell you anything. You can do a bunch of stuff for free. The entire workflow has been covered by Stoplight Studio, our editor. You can write stuff. Spectral is the linter. Prism is a mock and a proxy server that can do contract validation. We've got hosted Prism, so that's a mock server as well. We've got an analyzer that will automatically analyze the content of your GitHub, GitLab, Git whatever, based on webhooks, so you don't have to build your own analyzer anymore. Like this whole thing, everything I did at WeWork can just go in the bin, which I'm sure it already has, and it can be replaced with simple Stoplight stuff. And yeah, the benefit is real pretty GUI, so you don't really need to know too much about OpenAPI. You can just kind of use the built-in editor. And yeah, it works with Bitbucket, GitHub, GitLab, and Azure something, I've forgotten the name. We support more things than I even can remember, which is pretty nice because, like I said, I don't want my files being trapped in a walled garden. With previous versions of Stoplight, they had like a hosted version of GitLab and all your files would be in there and you could do this awkward export to get them out. But I think that the benefit of design first, or the benefit of having the OpenAPI files as a machine readable thing, is they can live in your repo with the code. They don't need to be in the same file as the code because that adds all the problems that annotations have and just the weird proximity of stuff. But you still want to have them in the repo so that somebody can make a change to the code and make a change to the OpenAPI. And because it just integrates with your existing Git, it does that. You can use Studio Desktop and you just open up a folder and it will look at all of the local files and you can edit them and push them back. And if other people want to use Vim or whatever else, they're more than welcome to. People don't have to all use Studio. It doesn't matter. The people that might want to use it are people that don't want to mess around with all of, one of, any of, and other complicated things in OpenAPI. You can do all the refs and all of the everything, just simple GUI. It also has a bunch of like docs and markdown articles and stuff. But what I really like about this, so I built something called Specky, and Stoplight ended up kind of rebuilding it and making it better and baking it into their stuff, which made me really happy. Basically, one of the hardest parts I had at WeWork was getting a bunch of people that only recently just learned about OpenAPI to write good quality OpenAPI. I mean, firstly, I was trying to make them write valid OpenAPI. They were just writing absolute nonsense. And so we needed to validate it. But beyond being valid, I wanted to make sure it was useful, right? Like people would not know that parameters could have a description, or they just wouldn't bother writing a description. And you have all these wonderful things like, created at, this is the created at date, name of user. And it's just really useless information being put in there. So this recommends you actually put in a description to tell people what that thing's all about. And yeah, you can customize the rules that come up. So you can like downgrade the severity or just turn them off. And you can make your own as well. And so this is called API description linting, sometimes known as kind of making a API style guide. You can create your own style guide that has all the rules that you're interested in. And I started making an APIs you won't hate style guide so that like you don't necessarily need to read that book. It just kind of puts everything into the style guide. And because you don't want to make sure that only the people using Studio are getting all of these rules and all of this information, all this help, there were a few points in this life cycle. We mentioned lint, right, in the development cycle and in CI. So I built well, I and other developers have built a bunch of integrations. So you can run Spectral on the command line, and this one will shout at you for saying, why, so someone's written a URL which is /_, and it's like, why are you using underscores? This should be kebab case, right? So you can do that in VS Code or in the CLI. And the benefit of this is that the benefit of using this linting when you're using design first is that you're actually affecting the shape of the API. You're changing how the API will look before it's even created, right? You don't have to worry about fixing inconsistencies after things are already in production when it's really expensive to change anything because deprecation is hard and slow. You can actually affect the design of the API before it's even created. And I tried to get real adventurous with the rules. I'm doing a whole talk tomorrow about automating style guides, and one of them is, okay, so you've got this hello path has a response with an error. It's a 400, and the content type is nonsense /JSON. This could be application whatever. And the rule that I wrote is basically looking to see if it has RFC 7807 or the JSON API error format. And if it doesn't recognize the MIME type as being that one, like it's application /problems plus JSON or something, if it doesn't recognize it as one of these two specific error formats, then it'll actually throw an error. And so with this one rule, I'm making all of the APIs that anyone creates from this step on use the correct error formats. So I'm actually adding consistency to the entire ecosystem where there's like 50 developers. So that was pretty cool, being able to do stuff like that. Mock servers, there's two different types, local and hosted, a bunch of tools online. And so with the local mock servers, again, if you've got an OpenAPI.YAML, you can take a tool like Prism or API Sprout, or there's a few other kind of open source CLI tools, and you just run it by pointing it at that OpenAPI file, and it will create an interactive HTTP server that you can, use curl, you can use Postman, you can use whatever you want. You can call it from your iOS application, and you can make requests to it, see how the API responds. You will get realistic validation errors and everything else. And there's hosted mock servers, which are, you can't like play around with them quite as much, but it's easier to use for people that don't know how to run CLIs and stuff. You can just share the URL. So this is how Prism looks. You start the server up, get a port, it tells you what URLs are available, it tells you what methods are usable. This looks pretty similar to like the Laravel startup screen, or how it used to look last time I looked. And it will also give you information like, hey, this request did not pass the validation rules. And it will, what else does it do? A bunch of other stuff. And then with mock servers, same kind of idea. You just have your workspace. So ACME, stoplight.io/mocks/widgets. And that's the URL that you're hitting. So you can just share that with someone. They can make a request to it, see if it works. So that's nice and simple. And with the hosted stuff as well, what's great about this is that it will use Git webhooks in the background to automatically update. So whenever someone merges any PRs or whatever, it goes to the main branch, it will just update. So getting pretty close to going through all them questions that I was struggling with a few years ago. And documentation is pretty simple too. Again, seeing as the OpenAPI YAML files are just in your repo, you can use any CI deploy process you want to just create HTML and push to S3. If you look at openapi.tools, there's a bunch of tools on there for documentation. You can look at Redoc, really good open source tool. You just run redoc bundle openapi.yaml, and it will create HTML that you can then shove on S3 or GitHub pages or wherever you want. Or you can do things kind of the Stoplight way. We have hosted docs that are totally free. You put custom domains on them, totally free, and it will just read from the Git repo when you push stuff. So you get all this like API reference documentation without doing anything, and it's always as up to date as your Git repo is as well. It doesn't do SDK generation. We haven't really messed around with that too much. No one's ever happy with like predefined SDK templates. I don't know if any of you have ever had any success, but I always find it's like a, one example would be like buying a suit off a rack. It's never going to quite fit you properly, right? Like if you want a really good one, go get one custom made to you or something. But so a fair bit harder to do that. So we don't really mess around with SDKs. We do give you code samples though. So anyone looking at your documentation can look to see how the code works in Ruby or PHP. I think there's a few different libraries in there. I think Guzzle is in there. And they can just get that. So instead of just looking at documentation and not quite knowing how to make the next step, they can copy and paste this code into their what's it called? Boris? This is the PHP one, right? There's a few of those REPLs, the interactive command lines, and you can just kind of play around with it in there and then move that into the code once things are working properly. So the last really hard part is kind of how do we keep keep the code and the API docs in sync? And this stumped me for a really long time. Basically, the visualization of the problem is this. You have a bunch of API source code where you've written a bunch of validation rules for all your different models. And then you've gone and written that same information in the API reference documentation, right? Sometimes people do this. It could just be a bunch of Symfony validation code over here, and then OpenAPI on the other side. You could have written it in, HTML or in a Google Doc, but if you've written it in OpenAPI, you have a lot more options of what you can do. So instead of having these two sources of truth, I mentioned something before, which might not have made too much sense at the time, about reusing API descriptions actually as code. And this is kind of a new idea to a lot of people and a bit voodoo magic, but think about it. With your server-side validation code, where does that code actually go? Do you put it in the model or do you put it in the controller? If you put it in the model, then it's kind of, bloating. Sometimes you're putting kind of a bit too much business logic or a bit too much weirdness in with your data stuff. And sometimes some of those validations may only make sense if you're you might use the same model in a few different places, like an admin versus like a user controller, and they might have different roles. So that gets a bit tough. But do you put your validation in the controller, which means if you have multiple controllers, you've got to duplicate that logic. Some people put it in the view. I've seen this happen. It's super weird. Sometimes people make a new service class, which is just some type of class or repository, they call them randomly in PHP half the time, or a contract class. So in Ruby, it looks like this a little bit, something called try. And you kind of define a bunch of parameters and you say which ones are strings and integers, which ones are required. Email might have a awkward regex that you have to shove in like that. And you can put in custom error messages if the value isn't big enough, whatever, right? Like people write this sort of stuff in their APIs. In JavaScript, this actually doesn't look so bad, but this is the nicest one I could find. The rest of them wouldn't fit on the screen. And this one actually recently got deprecated because I think the maintainer said he wanted like $750,000 to keep working on it or something. I have no idea. But people write all this stuff. You shouldn't need to. It's, in my opinion, like wildly unnecessary because you've already written this stuff in the API design first workflow. You've already written it all in this machine readable format that a bunch of different tooling supports. So why would you need to write it again in JavaScript, and why would you need to pay $750,000 for that? Basically, a lot of this talk is that multiple sources of truth just means checking for lies. And so if you can use that one source of truth in different ways, you don't have to check for lies anymore. Dread kind of started this thought process off for me. And basically, Dread, I used to be a big fan of it. I've done some blog posts on it. The idea is it will look at your OpenAPI or API blueprint. Why does I keep popping up? Am I over time? Ooh. What's going on? Did I mess up? No, I'm good. Right. Dread basically will look at all the different endpoints in your documentation and then look at all the different schemas and properties and values and try to create example requests for every single one, and then it will fire those requests at a real running API. It could be a staging instance or a whatever local host, and then it will look at the response, and if the response comes back funny, then it will say there was a problem here, and maybe the problem was that your request was bad, that means your documentation is bad, or the response was a different data type, like I was expecting a string but I got an integer, right? This sounds a bit like contract testing, but kind of isn't. It's not testing that you know, if you have a test suite with a bunch of requests and responses already, you're not asserting that those responses are good. You're just asserting that the examples and the requests and responses in your documentation are good. So you can let all these kind of bad requests and responses sneak through and fall through the gaps. And Dread also, it kind of works in a weird way where the state persists. It's just a HTTP client essentially that's making a bunch of requests to a real API. So it's a weird test suite, because if you create something and then delete it, well, if you delete something in one test, then you try and get it later, it's gone. So you have to make sure that all of your tests are okay with all of the previous things that happened before it. And so like if you do, you know, if you're saying, oh, this person has 2 friends here, but you have another test where it like adds another friend over here, then now they have 3 tests and you have to update everything. It's really annoying. So I don't like it too much. I think there's an easy way of doing it. Instead of making a brand new test suite to find out if it works, we can do the thing where we reuse API descriptions for validation. And so the way it looks is a bit more like this. You already have your description document. And so you can use, you generate your reference documents from that, but you can also make your API look at that for things like validation. So this is where validation middlewares come in, and you can basically do validation with no code. In PHP, it looks a bit like this. If you're using Slim, I think it works with anything PSR 7 or PSR 15. This is just an easier example. You can use, I think it's just called, from the PHP League, which some of you might have heard of. And OpenAPI Validation is the name. You pass in the OpenAPI.yaml, create the middleware, and pass it into the application. And that means that whenever someone makes a request to any endpoint that's defined in this OpenAPI file that's also routed to in this application, it can just spit back errors. If you're a Ruby person, looks like this. There's a tool called committee that does the exact same thing. And yeah, generally, it will just automatically create errors for you. This is, again, RFC 7807, but most of them will let you kind of define your own error format, so it will work however you want. But it means that you can you don't need all that logic that does all the validation. It just does it from the OpenAPI file. And these exist in every single language. So you're not kind of locking yourself into a language. Yeah, you can do it with whatever language you're using. You can switch languages later if you choose to. But, so what this means is if you're doing design first and you haven't written any code yet, then great. You don't have to write that code in the first place. But if you already have validation code, then you can delete it, right? Because some people are playing catch up from code first. So you can actually get those people closer to being happy with having OpenAPI and those YAML machine readable files, because you can help them just delete a bunch of code and it will still work in the same way, so long as they actually wrote the OpenAPI correctly in the first place. And if they didn't, well, at least now you know your documentation was wrong. People often like to say, oh, we caught out a problem with your theory here. Data store validations aren't going to work, right? Like you're not going to find out if the email is unique or not. And that's absolutely true. You do still need some validations, but in my experience, it's like 5% of validation rules or even less hit the database. Most of the time, it's just like, is this the right shape? Is this the right format? Is this whatever, more than this value? So you can massively cut down your validation. And then that covers the requests. You know that your documentation is correct, but what about responses? You can use some of these to validate responses, but if that code goes into production, you're kind of wasting server time checking that the response is valid when the response is already going to the user. So you bloody hope it's valid. And if it's not, well, you should have caught that earlier in your process. So your test suite that you already have, hopefully, can contract test them responses with a bit of code like this. Sorry for all the Ruby. Got a whole talk about it over here on apasyouhate.com, whole blog. But basically, you make your request, and then I mentioned the references. You can actually split. So instead of having everything in OpenAPI.yaml, you can split some of the schema files, some of the JSON bodies into other models, and then you can reuse those models later. So here I'm going to say, get me this user, and then with the response, assert that the user model works. So that's going to be user.json inside this folder. And that means you just have contract testing. Simple as that. You've taken something that you wrote originally for designing, and you all agreed through the process of using mocks that this was a good contract, And now you're writing a bunch of code that conforms to that contract and creating tests that prove that. And then because you're referencing those same files in your documentation, you know for a fact that your documentation is accurate. So you're onto a real winner here. Like, things can't get out of sync. They're all the same. Somebody pointed out, oh, I don't know, this validation might be a little bit slow. And it depends on the tool you use, but you can do something else which is a little bit crazier. You can actually use request validation in an API gateway, and a bunch of different API gateways support them. Don't really have too much time to introduce the entire idea of an API gateway, but basically they do a bunch of things like, you know, rate limiting and authentication. They can equally well handle validation for you, because all of your validation rules, or the vast majority of them, are baked into that OpenAPI file. It means you don't need to bother your application server with requests that aren't valid. You can just return them. Kind of like the same idea as a cache server, really. Requests come in. So someone's making a post, a client is making a post, it hits the gateway, bit of validation logic runs, and half the time this is written in Lua or Go or something really crazy hyper efficient. And it's been nicely optimized by a bunch of people who it's their entire job to make it quick. So this is usually quicker than whatever middleware you're running. If it is good, that request is then repeated to the API server, and great, it'll trickle back through. But if it's rubbish, then your API server has just continued along with its day, and that didn't even make it to it. So that gets a little bit harder for testing, because you don't want to introduce an API gateway to your dev environment. So what you can do is use a middleware in the dev environment and register a gateway in production and staging, probably. And then theoretically should, air quotes, because they're two different standards compliant tools, they should have dev prod parity, right? Like a request should work in one and fail in one in the same way. And if they don't, send a pull request, fix the tool. I'll blaze through one last place where there's another source of truth that sometimes gets out of sync, and that's the client-side validation. I've seen this a bunch of times where the API is doing one thing and two other clients are all kind of copying the logic, right? The mobile app and the web app have both said, okay, the max length that this string can be is 20, and it can't be any longer than 20. And they've copied and pasted that from the documentation that you've just wrote, which is perfectly up to date. But you make what you think is a non-breaking change to the API. You increase the length to 40 characters because Germans tried signing up and they have long names, it's hard. So, okay, now we have a problem. The web app has updated it to 40 characters and the mobile app hasn't. So what seemed like a non-breaking change has actually caused problems, right? Because this longer 40 character name has been entered in the web app, has gone into the API, and when a mobile app user tries using it, one of a few things is going to happen. It's either going to truncate that name to 20 characters, or it's going to, when they try to change some other field that's not their name, it's going to say like, that's invalid, you can't use that name, or a bunch of other different like weird, or it just like chops it off, a bunch of different problems. So a lot of things that you think are non-breaking are for your ecosystem, like validation hell, I call it. Something you can do to get around that, we've already split this user model into a different file and used it for contract testing and documentation, but you can actually make those files available online. And if it's JSON schema, you can use the rel described by and just shove this link. So when someone does a get, they know what your user looks like. And so they can use a JSON schema validator on the client side. So pretend they just downloaded this JSON schema file from the internet. You've wrapped up AJV, this is JavaScript, whatever. And then you try and create a request and that will validate. Then if you change it so the email isn't a valid email address, then you get an error back. That's like keyword type should be a string, whatever. And so using a little bit of magic, you can create your own error messages from that. You can look at different kind of types of errors. You can look at different messages. You can look at different the things that failed, and you can basically, all of these were created from AJV because this one had an example. I'm able to say date of birth was an invalid format. It should look like this, and all this other stuff. And you can use it to internationalize this and comprise those strings instead of as pure English. You can make them with different translations. So yeah, basically the whole wonderful thing of the design first workflow is that you are creating a machine readable set of validations and descriptions for your API that can then be used through the entire ecosystem for reference documentation, for web apps, for all sorts of stuff. And you only have one place to update it. And so just to remind you, yeah, design the API, mocks and docs, get your feedback, use that contract as code and as tests, deploy that stuff straight away along with the docs. And then whenever any new functionality comes in, it's just all going to get updated magically. And if anything breaks, your test suite is going to fail. So it's not going to get out of sync. It can't get out of sync. And then that whole crazy thing is totally possible. Look at different parts of these and think about how OpenAPI can help with all of it. And if you have any questions, I think I might have gone a little bit long, but yeah, all right, maybe. What do you think?
There's a couple of questions in the chat.
Ooh,
one from Mark, a couple from Mark actually.
Nice.
Franklin.
Okay, Franklin. Talk about OpenAPI for REST services. What about GraphQL, SOAP, gRPC, or functions? Yes. So basically, I wanted to mention SOAP. This stuff, OpenAPI is basically very similar to WSDL. It really is like a super similar idea. You know, they had XML schema, we have JSON schema. WSDL's fell out of flavor a bit because I think for a lot of reasons, but they just were a bit clunky and annoying, and folks got a bit fed up with them. And kind of as people went away from XML, they kind of went away from the ability to use WSDLs. So a lot of this stuff is very similar, but it's also very optional. You're creating this kind of open API description that you can then, you know, clients can use it and everyone can use it if they want to. And if they don't want to, they don't have to. So it's very similar to WSDL, but it's not a required part of the client's interaction. You know, it's like optional types, which in PHP, I'm sure you're very familiar with. So that's pretty good. When it comes to GraphQL and gRPC, yeah, like I'm talking about HTTP APIs. The concepts for code first and design first exist equally in gRPC and GraphQL, but the communities have attacked those in a bit of a different way. GraphQL seems to have fallen really hard on code first because they don't get a huge amount of benefit out of the design first stuff. The type system that they use doesn't really have as much stuff in it. So you can kind of, for them, their type system is more like serializers. They just create their serializers in code. They call them resolvers, right? Like you create your GraphQL resolvers and then you infer the types from that. But that's because it's quite easy to do. You could do the same thing in Laravel. I forget what they call their serializers, but I made Fractal or whatever. You could have Fractal serializers and you could say, this is a string, this is something else, this is something else. And you could easily infer from that the types. But yes, there are other conversations about design first or code first that you can have in the GraphQL community, but this is about HTTP, not specifically REST, but HTTP. Other stuff. Stoplight considering a more domain-driven design-ish features to plug into larger design processes. Seems to waver in and out of vogue. Yes. So if I'm wondering, not entirely sure what you mean there, I guess. Like UML style kind of designing, or maybe follow-up question for clarity.
Sorry, it might be easier if I come off mute, but yeah, so APIs are just sort of like one part of some broader design processes.
Mm-hmm.
So for like ontology modeling, to go back to the graph database conversation we were having earlier, is sort of like the first step of that. Like the API is one of those steps. So I was wondering how Stoplight thought about plugging into a broader process, or, you know, like some people do ARC42 stuff, some people do ADRs, but it seems design first opens it up to sort of a very broad concept of stuff it would need to plug into.
Yeah, I have seen a bunch more kind of classical UML style modeling tools around, called like JSON schema editor and things like that. I think there are plans for more kind of visual, kind of like when you think about like ERD diagram modeling tools, there are plans for some of those because some people work that way. If you look at like visual
Yeah.
GraphQL editors, then those things kind of exist for GraphQL, but not really so much for OpenAPI right now. But I think they're trying to stick to the slightly less technical approach for now. But
I mean,
yeah,
they're all incredibly unpleasant, so that makes sense.
yeah, yeah. There's a few around. Check out openapa.tools. I mean, the benefit of like the beautiful thing of this is that Stoplight doesn't need to make all the tools. You know, like some people will be happy using just Vim and just doing it all themselves, and some people can use Studio if they want, and some people can use whatever. And if you find that using like a JSON schema UML style modeling tool works well for you, and then you can export that to OpenAPI and you can kind of tweak it from there, and your technical writers can go in and kind of add more text to it and stuff like that. That's great. Like it's a whole just ecosystem of compatible tooling because everything's just looking at these machine readable standard format files that can kind of, you know, all interact in different ways. Ooh. Content management systems used to develop API portals with docs. Yes. Okay. So the question is, are there any kind of content management systems that develop API portals with documentation, specs, mocks, and the rest of it? And no, there aren't that I know about. Statamic is something I plan to build an extension for. I've been using Statamic v3 and it's awesome. It has a built-in API, which calls itself REST. It's just HTTP endpoints really, but I would love to have it, but because it's kind of the same idea, like Statamic really could look at OpenAPI and build a lot of those kind of blueprints and data types from it. But you can also do it the other way. Because you're saying, I would like a collection of widgets and widgets will have these fields and these data types. You plug all of that in through an interface. It takes a long time, but once you've got it, you could easily make an OpenAPI from that, and that could give you mocks. I mean, that's code first with an interface, right? But you could easily kind of build OpenAPI docs and stuff from there. So I'd like to look at more integration between CMSs. If you look at API Platform and I forgot the name of the other one, but API Platform is a good place to go. They have some support for this stuff. To stop, I consider validation, request response specification, test APIs, drills. Yes, so Prism has a proxy server, and basically just like running a mock server, you run Prism and you pass in the OpenAPI file and you pass the upstream server that it should go to, and that could be production or whatever, or your local host. And then basically all the requests go through the validation server, very similar to the gateway model I talked about. And basically it will say like, you're missing a field from this request, or this is the wrong type, or you have too many properties or whatever. And it will blow up so that you can fix that. That helps with end-to-end testing. It also helps with like front-end developers who are trying to implement the thing. They might have started off trying to implement the mock server, and then halfway through that process, the API team said, oh, we finished. Here's the real one. Go use the real one. And so instead of using Prism mock, you use the Prism proxy server. And you'll get feedback on how your integration is going. So it will just blow up at you if you do something wrong. And equally, it will look at responses too. So if the API that you're trying to integrate against says that it's going to offer you various different properties and it doesn't, or they're different data types, then you'll see an error message about that too. And you can go and shout at the API dev team, or at least know that that file that property isn't gonna be there. So, yep. One more sort of trivial OpenAPI side question. Have you seen many projects adding links fields to the OpenAPI docs to make it HAL Hatios flavored? Yeah, OpenAPI currently doesn't really help you out very much with Hatios. Most hypermedia controls exist either in links headers or in the JSON body somewhere, and so it's my opinion that like those formats already handle their own Hatios. So OpenAPI can give you some hints. It will say like somewhere in this response is a link that goes to this other related thing, or is a pay button for your invoice that you can click if you want. but it doesn't really help you understand specific data formats. Like OpenAPI won't help you understand how links or JSON API links or Siren links. It will just say like, this is a link to that. It's not very good yet, but that is something that should happen in the future. Thank you, Mark. It's very nice. Oh, cool. I'm getting some answers in here too. This is great. There is a Drupal module for OpenAPI, so that's really cool.
Yeah, I've not used it myself, but it's pretty up to date. It's updated 2 months ago.
Yeah, that's great.
It's used on the Contenta CMS distribution, which is pretty cool. Yeah, I'm gonna check that out a little bit after this as well.
Nice. One more from Steve. When building an OpenAPI specification, is this separate from something like JSON API, or can you enforce JSON API standard through validation? Yes, absolutely. So yeah, I run the APIs You Won't Hate Slack channel, kind of made a whole community out of what started off as just a place to chat about the book or whatever. And this question comes up really often. People are like, should I use OpenAPI or JSON API? But the names could be better, honestly. They aren't competing standards. There's different types of specification that you're going to have involved with different parts of your API. Things like GraphQL are great because it's all in one package. They tell you how to write types, what shape your information should be in, and all these other things. But with HTTP APIs and REST, you kind of have to like comprise some of those standards yourself. So you might have, RAML describing the entire. You might use RAML as your API description, and then HAL as your message format. But you can use OpenAPI to describe how everything is, describe what all the information means, and you can use JSON API to kind of enforce standards on what shape that data will be. So JSON API is, I call it a message format. It's like a data format, it's a message format. And then OpenAPI is the API description format. So you can use them both. JSON API shapes the actual JSON that you're sending over the wire, and tells you how to handle relationships and tells you how to handle pagination in some ways and URLs and stuff. And then OpenAPI just kind of is metadata that describes what some of that information might actually mean and what some other potential values might be, and some examples for those things and more validation rules, So both is good. And with that, I think I'd like to stop talking. Thank you very much for letting me do this.
Cool. Thanks very much, Phil. Yeah, if you want to send us the link to the Slack channel, maybe we'll tweet it out afterwards as well.
Great, will do.
And any other things. Yeah, some really good comments from people there. Thanks, Mark, as well for your talk. Equally great comments we were seeing earlier on.
Cheers to Phil. I really enjoyed that.
Thanks, folks.